Hi, I'm Michelle Maharbiz,
And I'm Tom Zeidel.
and as we promised, we're back looking at resistors.
All right, so we're back to the breadboard with the very first circuit we made, our little LED circuit. Now, as we promised, we're going to talk a little bit about what this resistor is doing here, because I'm not sure we even need it to make this LED light, right? So what's that resistor doing, Michelle?
So if you remember our water analogy and our electric circuit, in the water analogy, we sort of modeled the resistor as changing the diameter of a particular segment of pipe. And you can imagine in that water analogy for a fixed height source, which is that little guy pumping water, as I change that neck, that diameter of that little piece of pipe that we're calling the resistor, it produces more or less resistance on the flow of water, and so you'll get more or less flow actually going through it. So the resistor in that electric circuit is doing pretty much the same thing. The resistance value is somehow for that fixed value of the battery that's providing approximately 9 volts, it seems to be restricting the current through it to different levels. But it's sort of our job today to figure out why and to come up with an analytical expression. One thing I will say is that we know the LED's brightness is related to the amount of current going through it. So if an LED has more current going through it, it should be brighter.
I see, so we should be able to switch this resistor for other resistors with different resistances, much like swapping in that pipe with pipes of different diameters.
Yeah, so let's do that real quick. It's a really quick experiment. So we've got a resistor there now. What resistance is that?
That resistance is 300 ohms.
Okay, I pull it out and put in, I don't know, something higher?
Yeah, this resistor here has a value of 4.7 thousand ohms, or 4.7 k ohms.
And so I can just barely make out a glow. It's like almost imperceptible. I doubt even people on the camera, the video can see it. But okay, so why don't we put on something with a lower resistance? So that should be a lot more current than the original one, right?
That's right. We should get more current and therefore a brighter LED.
All right, let's do that.
So here we've got a 51 ohm resistor, and it's a lot brighter.
Yeah, okay. Okay, I can't resist. What if you just put a short? Like, let's just put a wire.
Just a wire?
Yeah, now, I mean, wires don't really have zero resistance. They have some tiny little bit of resistance, right? But I mean, that should be a lot of current going through that LED.
Yeah, I don't know.
It's going to be awesome.
Is that good? Oh,
whoa,
it's yellow. I'll take
yellow.
it out. That doesn't look like it's good for the LED.
Yeah, so that's a probably inappropriate amount of current. So it actually, do you know why that happens?
No, tell me, why did it change colors? This is supposed to be a green LED.
Yeah. So what happens in that case is that too much current is flowing through and it's overheating, and as a result of overheating, the sort of diode that's on there, it actually changes the spectrum of light emitted. It's actually changing the color of the light emitted. You shouldn't do that at all.
Wow, that's fascinating,
Okay.
But yeah, it seems like that's bad for the life of the LED.
All right, so let's put up an expression for what resistor does in the context of voltages and currents.